drawing that I have made. As straight as these lines get, guys. There's no ruler that comes with this app.
Maybe?
No. All right. So number 2, right, in section 7.2, that's the only one they asked you to do? Okay. So we're dealing with similarities as opposed to congruent. What is the biggest difference between similar polygons and congruent polygons? Don't know the answer that one.
When polygons have the same shape but may be different in size, is similar.
When polygons have the same
Shape but different in size.
right. So when we're talking about similar, oh, this person looks similar to you, we're not necessarily talking about your twin, we're just talking about that you have similar traits, yes? Is the angles of polygons all have to be what? They all have to be equal. So the angles stay the same. So between similar polygons and congruent polygons, the angles have to be the same in order for this to work. It's the sides that change. Okay? The sides don't have to be the same measure, but they have to be what? It's a term from 7.1.
Proportion.
They have to be proportionate. Does that make sense? So if one side is 3 times bigger, then all the other sides have to also be what? 3 times bigger, and the scale factor is being 3. Yes? Okay. So in this case, before we check anything is similar or not, or proportionate, we need to check the sides. I mean the angles. And the angles have to be what?
Equal.
Equal. Yes? Yes. So we have here, because Miss P lost her laser. Okay, we have here angle A has to have an equal corresponding angle on the other polygon. Does it?
Yes.
To which angle?
E.
But also to angle
G.
G. Yes? So what we're going to do here is we're going to have, we know that angle A is equal to angle E. Yes? Angle B is equal to angle. Angle C is equal to angle.
G.
And angle H is equal to angle. Oh, that's wrong. Angle D is equal to angle H.
Does it matter? Or?
It does matter. Well, they should all be on the same side of each other. Okay? So this is check. We're done. Right? With the angles. It's supposed to be a check sign. Okay? But now we have to check what? The sides. We don't have to check if the sides are equal. One more time, we have to check if the sides are proportionate. Yes? So that means that each corresponding side, when I actually divide them all, I have to equal my scale factor, which is equal. So let's ignore the numbers right now and let's just focus on which side should be matched with which sides. Does that make sense? So let's look at the sides. AB should be proportionate to what? EF. Okay. BC should be proportionate to
G.
CD should be proportionate to
GH.
and AD should be proportionate to
BH.
Good job. Here's the thing. Does it matter which one is going to be on top? Now, they'll ask you if they ask you specifically what is the small in ratio to the big, yes. But in this case, it doesn't matter which one I put in top, I just have to be consistent throughout the whole time. Does that make sense? So if the smaller one is on top, then it has to be on top for all of them. Or else you're going to have different measurements. Does that make sense? So if the bigger one is on bottom, then all the bigger ones have to be where? On bottom. I can't mix and match. Now I can have all of the big ones on top and all the small ones on the bottom, that's fine. But as long as I don't mix and match. Do we understand that? Because once you get the numbers off, once the scale factor is off, then you're going to have problems. So it's very important that you understand the labeling of this. Do you have questions, comments, concerns? All right. So in this case, we went from polygons to what specific?
Triangle.
We're dealing with triangles, yes? Okay. And just like when we're dealing with congruent triangles, similar triangles have shortcuts. You with me? So I want you to open your book so we can look at our shortcuts.
397.
397, which is what? What's our shortcut? 397. The angle shortcut. What does that mean?
Two angles of one triangle are congruent to two angles of another triangle within the triangle.
Right. So if I can prove that at least two angles are
Similar.
congruent, right, equal, not proportionate, I'm saying they're actually equal, then I can assume the triangles, no matter what, are similar. Does that make sense? Class, yes?
Yes.
Okay. The next one is what?
Side.
Okay. In this one, if I can prove that three sides are, are what? Proportionate. If I can prove, without any of the angles, if I can prove that three sides of a triangle are proportionate, then I can assume that the angles are what? I mean, the triangles are similar. We're dealing with similarity here, not congruency. Okay?
Cut that part out.
What?
You're going to have to cut that part out.
What part?
Put that as well.
No, I'm going to put that on there, and then I'm going to put your name on, Zachary Mayer.
She shows her.
I know.
The last one is what?
Side angle side.
Side, angle, side. This has one congruent angle, but two
Two sides are proportional.
proportionate sides. Yes?
Yes.
One more time. The angles need to be
Two proportional sides.
congruent. When they're dealing with any angles, they need to be what? Congruent. But the sides need to be proportionate. Do we understand? Okay. So, let's look at this. Which one, through process of elimination, are we going to be focused on?
Side.
What?
Oh.
Side, side, side. Why?
Because they're like they show two sides.
Because none of them have angles. They're not giving you any angles in this picture, right? They're giving you only sides. You with me? Okay, so if they're dealing with only sides in this picture, I mean in our picture, so basically if we prove that all sides are what? No. One more time, all sides are proportionate, then they are similar. One more time. So now let's plug in the numbers. DE is,
25. Oh no, 25.
AC is,
100.
which is? I don't want a fraction within a fraction, so let's put it in decimal.
What? AC?
925.
No. AC is, AC, sweetie, AC.
Oh, wait, AC. Oh.
What is it, guys?
35.
Huh? 8 point what?
8.3.
8.33. EF is
21.
CB,
7.
and then FD, and then BA is 3. Yes?
Yes.
So let's do the math. 25 over 8.33 is 3.00 something, right? So it's 3. Yes? We rounded to 3. Yes? 21 over 7 is? 9 over 3 is?
So yes.
Are these all proportionate?
Yes.
Are the sides equal?
Yes.
Yeah.
No, the sides are not equal to each other. The sides are not equal to each other. Their proportions are equal. Does that make sense? I can't emphasize that enough. We got it? Okay. So, what shortcut did I use?
SSS.
So I can say that triangle DEF is what?
Similar.
Similar to triangle ACB. I have to name it the same, corresponding angles, right? Because of what?
Side.
Side, side, side. Yes? Questions on this?
You have to put side, side, side.
That's the reason, yeah. That's to justify. What it's telling you is to find x. So we're going to combine what we know from section 7.3, okay? And then combine it from 7.1, which is the fractions. Do you remember that you did in 7.1? Probably your favorite section because you only had one section that day. So before anything, let's set up our proportionate sides. Yes? I know that BA, the reason why I know is because this has two curves. Do you see B?
Yeah.
And it has 1. So I'm going from 2 to 1. You see that? So BA, 2 to 1, is proportionate to what? DE, or ED, you're right. ED, 2 to 1. You see that? It's very important. This one, they're trying to trick you. They're drawing the picture, okay? They're drawing the picture upside down and different, so you have to make sure that you draw the proportions right. Because if you don't, then your answer is going to be wrong from the beginning. Are you with me? Okay? So, BA over ED, and then what do we have? AC, 1 to nothing, to what?
DF.
DF, 1 to nothing. Good. Okay? What do you mean DF? Do you see it? Because it's one curve. A has one curve and C has, you see it? Okay, good. All right? And then the last one is BC is similar, is proportionate to
Yeah.
EF. Yes?
Yes.
Are there any questions on how Ms. B set that up? Okay. Here's the thing. On 7-1, you were dealing with how many fractions before you can cross multiply?
2.
2. Yes? I'm not dealing with just 1. I'm dealing with what?
3.
3. Okay? I'm not dealing, but can I cross multiply with 3?
Yes.
No. No. I need to only focus on 2. But let's look at what they want us to have. They want us to have, X. They want us to find X, and they want us to find the measures of AB and DE, right? Do we need AC or DF? Okay, so just to help us out, we're going to cross that out. Yes? Are you with me?
Yeah.
Yes.
Okay, so we cross that out. What do I end up with? X over X minus 4 equals what?
5
over
over
3.
3.
This is the geometry of it, guys. Okay, before we move on, look at it real quick, the proportions, and tell me if you have any questions on how Ms. P got that. Any questions? Because from here, we just use 7-1. Does it make sense how I got that?
Yeah.
Yes.
Yes? Okay? Some of you guys are going to go ahead and try to skip that part where you set up all 3, but it's just going to get confusing. So if you don't know where to start, just start with all 3 proportionate sides. Yes?
Yes.
Okay. So from here, I'm going to go ahead and apply 7-1. What's my first thing that I need to do? I need to cross multiply, but you see how this is an equation? I'm going to bubble it. Yes?
Yes.
All right. So let's cross multiply.
X equals 10.
I end up with X equals, the negative and the negative cancel out to give me 10. Am I done?
No.
No, because it's not asking me for just X, it's asking me for
Measures.
A, B, and
DE.
DE. Yes? So, I know AB equals what? X, which equals 10. So that's AB. The next one is what?
ED.
ED equals X minus 4. So I end up with
6.
10 minus 4, which is 6. Any questions on that? Do we have it?
Yeah.
One more time. Are there any questions on how I got that? Pencils down real quick. I'm going to give you time to write it down. This is the last problem. I just need to make sure you understand. Do we understand how Ms. P got those answers? Questions on how Ms. P got them?
No.
No? Okay.